Well, good evening, all. Hope my voice is clear and audible to you all. Can someone please acknowledge whether my voice is audible and we are visible as well? Can someone please acknowledge in the chat box? Can someone type and tell me? Yes. Thank you, Parmarji. Uh, well, so Saurabhji, people started to join, so let them join. So first of all, I welcome you for this particular sixth webinar, which is conducted or which is scheduled by Skill Council for Mining Sector. So, dear participants, good evening to you all, and I welcome you all for this particular webinar. Before starting of this webinar, I would like to introduce our the guest speaker of today's webinar. He's none other than Mr. Dr. Saurav Ambastha. So Dr. Saurav Ambastha is an environmental consultant and he works for TJS Labs, Ahmedabad. Dr. Saurav Ambastha has 12 plus years of experience in industrial consultancy and academia. It's the deadliest combination, the combination of the industry as well as academia. And he holds a BTech and MTech degree along with his doctorate with a specialization of mining sector impacts. He's having a skill setup of multiple environmental and hydrological modeling software like ArcGIS, QGIS, ModFlow, AirMod, and various other climate software. Till now, with TGS, he has completed around 30 plus high-level projects of mining. You take a big name, so for all the companies he has worked with. Also, the projects of mining and industrial hydrology, and he has delivered 30 plus webinar trainings and given talks on skill development in prominent national or international, along with many research publications. So today, Dr. Sauraji will be deliberating on the importance of GIS survey, application of GIS in mining, how to become a GIS expert, what will be the GS expert salaries, what are the scope of this particular field, and what will be the nature of work, what will be the career opportunities and progressions in the field of GIS. And he also deliberate on basic introduction about GIS mapping, how to capture the data, how to analyze the data, and how to retrieve it, and finally how we are going to do process of GIS data work. So this is a brief introduction about our today's guest. So, sir, we heartily welcome you, and I hand over the session to you, sir. Please.
Thank you very much, sir. It is a privilege, and FIMI has given us a platform to actually give a little bit exposure to GIS to everyone, and what is the use of GIS in mining sector exactly. So that we are going to discuss in next 2 hours, and my team member will be here. If you'll be having any questions or if you're having any doubts related, small doubts, you can ask me even that I can clear. Or if you have something related to some maps related questions, you can just post into the chat box also. They will answer. So without wasting any time, we are going to proceed further, and we'll start our presentation, and let's see how much we can explore in this 2 hours and how much you people are going to learn from us. That is the objective of this webinar. Again, I'm going to thanks FIMI for giving us this opportunity, and let's start this presentation. Thank you.
Thank you, sir. The floor is yours, please.
So I think everyone must have seen this flyer, all of you, when you have registered this. And in today's webinar, we are going to discuss GIS and remote sensing. R stand for remote sensing, and then GPS also, then the application of GIS. how to become a GIS expert, career opportunities, and what are the GIS expert perspectives, and the uses of GIS in the mining sector also that we are going to discuss in details. Uh, so this is about our TGIS. We established in 2019. Until from 2019 to 2023, we have organized more than 80 trainings national or at national or international level, where 7,000 plus participants we have trained, and more than 150 cities people have taken the training from us, and the participation of countries was 30 plus in our organization. Uh, and more than 110 consultancy projects we have worked with, where there are 60 premium clients like ONGC, GMDC, and lots of mining projects. People you will find out in this one. In consultancy project itself, I have done more than 30 plus projects in the mining sector, and we actually deliver the handmade or custom made kind of lectures to the trainees who want to take training from us in the sector of remote sensing and GIS, and even in ModFlow and MOD. So this was our little bit journey till now, and we are the QCI in ABET approved FAE functional area expert in land use, ecology, ecology and biodiversity, hydrogeology, and air quality. Uh, so this is the webinar objective. I think I have already discussed it, but still, you're going to see in next 2 hours that we are going to discuss in this basic introduction about GIS mapping, capturing, analysis, retrieval, and processing of the data. Then how to become a GIS expert, career opportunities, and progression in the field of GIS. GIS expected salary, scope, and nature of work. So first of all, let us start with remote sensing. So I think you all must have heard about this term remote sensing and GIS. So remote sensing is basically acquisition of information about any physical any place without any physical contact with the object. The modern uses the terms generally refer to use an aerial sensor technology to detect the and classify the object of the Earth. So there are two types of remote sensing. First is passive, and another one is active. So passive remote sensing is most common, I think, like method in which radiation is measured by passive sensors. So here, in remote sensing, uh, actually the light which is getting or the radiation which is getting refracted from the earth, that is getting measured by the sensors, is called as passive remote sensing, and it is also called film photography or infrared kind of things. So active collection is, on the other hand, which emit energy in order to scan the object, that areas where a sensor that can detect and measure the radiation that is reflected or back targeted from the target. Radar is one of them, radio detecting and ranging. LiDAR is light detection and ranging are example of active remote sensings, which are the time delay between emission and return is measured, establish the location, height, speed, and direction of the object. So these are the sensors which is related to the remote sensing: optical, visible, reflectance, near infrared reflectance, then thermal infrared, thermal radiation. So optical are those actually where the visible light range is available, and microwaves where the passive or microwave radiation actually takes place. That can be done in night also, microwaves. And in the absence of light also, microwave sensors can classify the things, objects, or and even optical is another sensor which actually works in the daylight. It can't penetrate the cloud cover. Microwave is another one which can penetrate the cloud cover also. I think all of you must have seen in spy movies or some military kind of movies where people are at night time. People are using different kind of equipments through which we can sense the body heat or somewhere, and through which they can identify whether what kind of object it is. So that is what a microsensor actually works on. It can penetrate anywhere, and it can see things from from the space or from the satellite. So these are the two sensors. So electromagnetic energy is the source which is required to transmit information from the target to sensor. It is very crucial medium uh, that is described an electromagnetic spectrum. On this spectrum, many forms exist that describe energy in a specific region or electromagnetic spectrum. These are visible light, radio waves, microwaves, ultraviolet rays, X-ray, and gamma rays. These spectrum is an overview of the continuum of electromagnetic energy from the extremely short wavelength, cosmic gamma rays, to extremely long wavelength. These diversions are not absolute and definite overlapping may occur. So this is the visible range actually through which optical sensor works on. As you can see, these are the UV, IR, ultraviolet rays and IR rays, and between that, the visible light through which actually which can be seen by human eye. Violet, that is a waveguide, and on a left hand side, you can see this is the shorter wavelength, and another side is a longer wavelength. So in shorter wavelength, this X-ray, this microwaves actually works on, and in longer wavelengths, where the optical sensor works on. So this is the light spectrum actually where through which the satellite sensors works on. And this is the one of the technique through which actually remote sensing satellites works. You can see from A, that is the source of the light, sun, emitting radiation, and it is coming to through B to the Earth, and that is getting refracted. Something is getting absorbed at the object, and the light is getting refracted to again to the space, that is D, and which is captured by the satellite, and that satellite is sending those information to the transmission, and through the transmission it is sending to the controller section, and from the controller section it is going to the processing center, which is G, and there you can see a image which is captured by the satellite. And these there are multiple kind of satellite through which actually this kind of works is basically usually take place. So scanning the process and the sensor. Along the track scanner, a remote sensing tool with a line of many fixed sensors that record reflected radiation from the terrain along a satellite direction of a movement, creating scan line strips that are continuous or that overlap slightly, thereby producing an image. A cross track scanner, which is this group, one is push broom and one is whisk broom. So there are the two types of actually scanning take place. Push broom is for smaller area. Whisk broom is for larger area. So remote sensing tool with an oscillating mirror that moves back and forth across the satellite direction of travel, creating scan line strips that are continuous and overlap slightly, thereby producing an image. So whisk broom is something which is the photograph is actually taking like they are capturing something with line, and they are overlapping, and after that they are what they are doing after the processing, you can see the full image. But in push broom is just producing an image from of small area. I'll just show you that, make you clear how it is working. So here you can see this is a remote sensing scanning system. In push broom section, you can see this is one cell where the scanner is targeting. The cell is 10 by 10 meter, and everything is actually fixed on this. So first picture 10 by 10, this is 20-kilometer circle, and you can see this scanner has started from this side, the left hand side, and this side, and this is moving towards this direction, and from one cell to one cell it is going to capture. So that's how it is going to make image in image by image processing. But in push broom system, what it is doing, it is taking one complete strip, and that's how. And again, it is going to come back. Again, it's going to take another strip, and that's how it is going to make one picture. But in this case, in Bix broom, it is going to take picture by picture of smaller cell, and that's how it is going to develop an image finally. So it is taken by Sabin 1997. This is a research paper. We have taken this image to make it clear how this kind of scanning system or sensor system works on the whisk broom and push broom system. So now we are going to talk about resolution. There are four types of resolution. First is spatial resolution. I think all of you must have heard about the spatial data and all everything if you're using GIS. So the size of pixel that is recorded in raster image, typically pixel may correspond square areas ranging the side length of 1 to 1000 meters. So this is the size of any pixel if you're going to take any spatial resolution or you're going to see. It may vary from 1 to 10,000 1000 meters. And then spectral resolution, it refers to the number of dimension of specific wavelength intervals in the electromagnetic spectrum to which a remote sensing instrument is sensitive. So here, uh, it always uh, defined with the numbers and the dimension of specific wavelength intervals if in electromagnetic spectrum, where the remote sensing instrument is sensitive. And then the radiometric resolution, these are the different intensities of radiations. The sensor is able to distinguish typically this range from 8 to 14 bits. This is a binary bits. I think you have must have used data cards or the pen drives, everything. So it is something like that where actually the range is between 18 to 14 bits corresponding to 256 level of the grayscale and 16,384 intensities of shades of color. Spatial resolution actually gives you data about how much the picture is clear to like anything. Suppose a cell is there of 1 by 1 meter, where you can see the things very clearly. If I'm going to take any picture from the drone, which is 1 by 1 cell, where the details will be very higher. But if the same picture is taken where the area is larger, so the details present in the picture may vary with the resolutions also. So that is how the spatial resolution works on. Suppose there is a picture of 10 by 10 meters, which is taken by one satellite, and another picture taken from another satellite, which is where the area is 30 by 30 meter. So the area which you're going to cover in 30 by 30 centimeter is always large, but the details present in 10 by 10 cell will be higher in comparison to 30 by 30. So I'm talking about clarity also or the details present. So in the zoom quality, you will find always the thing which is very clear in the smaller spatial resolution. Then there is a temporal resolution, the frequency of revisiting of the satellite or the plane. So this is what a band and width through which actually this is one of the bandwidth in which mining sector actually works on. So this is the Landsat 4 and 5 TM models and Landsat 7 ETM model, which has been actually developed, and later on they have improved it. So first band is blue band, where the wavelength is 0.45 and 0.52. If there is a presence of any water body, and you want to observe it and you want to see what is the area of that particular water body. So I'm going to use this blue band because the reflection of blue color will always give us the idea, reflection through the reflection of that blue color, we can actually identify with the help of GIS or with other softwares what is the area of that particular surface water body. So it is used in bathymetric mapping, discussing soil from vegetation and deciduous from the contiguous vegetation also. So this is the blue color, which is used for accessing the water body. And even in soil distinguish also if whether it is exposed or not. Then the vegetation of different type of vegetation in deciduous and coniferous forest type of things. And band 2 is between band 2 refers to green color 0.52 to 0.60. So from band 2 to band 7, that is the main area from where we actually works on in the mining region. So in this emphasizes on peak vegetation, which is useful for accessing plant vigor. So how much the vegetation is thick, actually that we can determine with the color composition. I'll show you some pictures related to that through which you can actually identify which area is more thicker and like where the vegetation patch is higher and where the vegetation patch is less. So we can actually examine with the help of the software. Then the band 3 is red, which is falling between 0.63 to 0.69. And that actually discriminate vegetation slope. Then the next is band 4, 0.77 to 0.90, which emphasize biomass contents and the shorelines. Uh, if you're going to emphasize on the biomass, which is actually essential in the mining field areas also. So that also we can examine with the help of near infrared wavelength. And the shoreline kind of things is essential on those area where mining is taking place in the shorelines kind of places. And then the short wave infrared, which is lying between 1.55 to 1.75, that actually discriminate moisture content of the soil and vegetation. It can also penetrate the thin clouds. So this is the one of the other contents to actually see what is the moisture content in the soil also. Uh, then the thermal infrared lying between 10.40 to 12.50, which is thermal mapping in estimating soil moisture. These are all related to the mining sectors only. And then shortwave thematically altered rocks associated with minerals deposit. So this is one of the most important feature where shortwave infrared is used for rocks associated with mineral deposit, which is very essential for the mining sector. And in 2.09 and 2.35 of wavelength, we can actually examine it. And another one, last one is panochromatic 0.52 to 0.90, which is having 15 meter of resolution, sharper image definition. If you want to see some kind of details in that certain area, for that, this panchromatic wavelength we use, and which is only available in Landsat 7. uh, where the 15-meter resolution and the sharper image definition we can see. So this is the Landsat program. I think all of you must be known to this, which is archived in United States at Landsat receiving station around the world. uh, for specifically which is a resource or a storehouse of global change research, application of agriculture, cartography, geography, forestry, regional planning, surveillance, education, and national security. So these are the Landsat satellite which when they have launched and when they have terminated the services. So currently, like 3 or 4 Landsat satellite is still working, Landsat 7, 8, and 9. These are stale function. Uh, let's let's move further. So this is the application of remote sensing. Till now, we have not discussed anything related to GIS, but remote sensing is one of the most important part of GIS only. And the applications are related to environment, forestry, geology, geography, hydrology, land use planning, military, risk management, transportation, urban planning, and rural planning. So I'll start with GIS. If you have any questions, please ask me. I'm just going to take a small break. If you have any questions related to this, you can ask me.
Sauroji, so what I feel,
Yes, sir.
let us keep the Q&A session at the last, Volke. Yeah,
Okay.
will
Okay,
that
sir.
be fine?
Okay, sir.
Thank you. Thank you
Okay,
very
yeah.
much.
Absolutely fine, sir. So this is GIS. Uh, GIS actually consists of two distinct disciplines, geography and information. Geography is a science which involves a combination of physical and cultural discipline, which used to describe, explain, help to understand our environment and our relationship with it. In other words, the description and distribution of various physical, biological, and cultural frames found on the Earth and interaction within them. Information system most often refers to system containing electronic records. This information system can be defined as interactive combination of people, computer softwares and hardwares, communication devices. Most common definition of GIS is it is a systematic integration of computer hardware, software, spatial data for capturing, storing, displaying, updating, manipulating, and analyzing in order to resolve in analyzing in order to solve complex management problems. So here you can see people are first taking the ground truths, then converting it into the data, then processor is there, then it is coming to the hardwares, then the softwares. So that's how it is working. So always we are having two kinds of data which we receive in GIS forms. So first of all is vector. So vector can be represented in point line, or polygon feature. So what is point in vector? First of all, vector actually represent if suppose I just want to give you one example. Uh, I think you all must be using uh, map features in Google Map in your phone. I think most of the people are having it right now. So suppose I want to just going to create one story. Suppose you want to check some restaurant or maybe some outlet like Pizza Hut or Domino's. You want to find out what you usually do. You just going to write on your phone Pizza Hut or Domino's near me. So it will give you the maps will start popping up with number of Domino's outlet or Pizza Hut outlet present near your location. So how this is happening? So this is somewhat the vector points where actually we do like they have put out there. We can do also this thing in the GIS. Then the point line example. So suppose you want to go to one of that outlet, which where you want to go. So what they will do, the moment you will start that the distance between the nearest outlet and you will choose that option at that time. Uh, uh, this software, what they will do, they will pick your latitude, longitude location, and they will pick the latitude and longitude location of that particular outlet, and it will make a line point line object and it will give you one distance. So that is called as point line. So, and it will show you the way. And the polygon is something which actually show you the area of that particular object. Suppose in mining industries, we just want to analyze the area of mining sector where actually the excavation is taking place. So for that particular region, we use this polygon kind of thing. And point features is used in mining industries to select different location, where we can put air quality measuring machineries, or air quality where we can put the explosive houses, where we can put this machinery, where we can place the offices in the mining area, and what will be the distance, and what will be the possible ways to get out from the mining areas. That can be done with the help of point lines. So in this, data conversion usually take place from one data format to another data. So this was all about the vector. And here you can see the raster feature. Raster feature is nothing. It is just a pixelate point, or it's a larger area. Suppose this is your area particularly, and raster data is one smaller area where you want to emphasize actually. So that's how this raster data features works on. So here, I think I have already discussed it, but still I just want to show you points can also be used to represent area when displayed at small scale. For example, cities on the map or the world would be represented by points. No measurement are possible with the point features. Line is one-dimensional lines are used for linear features such as river, roads, railroads, topographic lines. Then this is a polygon. Two-dimensional polygons are used for geographical features that covers a particular area of the Earth's surface. Vector data conversion. Converting a vector to raster represents involves overlaying the vector to raster and identifying the pixel that vectors intersects. This method used to rasterize polygons and line produce much more accurate results. So this was all about raster and vector data. Now I'm just going to move on global positioning system. So global positioning system, I think all of you must be using in your cell phones. And nowadays everyone is relying on this services, just if they want to go from one place to another place, if they want to check traffic also. So this is one of the most important feature which has revolutionized a common man life. And earlier days when the smartphone is not available, at that time people were relying on panwalas and different like chai wala, just to ask where this road goes and where is this place. But right now everything is marked on GPS system, and you will just put the address, it will come and it will take you to that location without any disruption, or it will always suggest you which way is better, where the traffic is less. So that's how the GPS system is changing the common man life. And even in this like mining sector also, it is playing vital role. The Global Positioning System is a space-based satellite navigation system that provides location and time information in all weather, anywhere or near the Earth, where there is an unobstructed line of sight or three or more GPS satellite. So GPS programs provide critical capabilities to military, civil, forestry, earth sciences, and commercial users around the world. History. Just let's discuss the history of this GPS. GPS project was developed in 1973 to overcome the limitation of previous navigation system, integrating ideas from several predecessors, including number of classified engineering designs studied from 1960. GPS was created and realized by US Department of Defense, and that was originally run with 24 satellite, and it became fully operational in 1994. So here you can see, so for one positioning system, that 24 satellite is working continuously to give you better results or give you better accuracy. This is how the GPS system is working. So you can see how the segments work. Space segment always connected with 4 satellite to give you proper accuracy. Then another one is control segment, which is always connected with those 4 satellite. And the user segment, as you can see, when you start using your GPS system on your phone, it will always connect it to 4 satellite to give you better accuracy. So you will find it out on your phone also. Sometimes it will say to calibrate your phone. You will just make 8 mark uh, in the air, and it will start calibrating. On our phone also, the accuracy of this phone is GPS system is almost near about 3 to 6 meters. The accuracy is 3 to 6 meters, which is quite impressive. Uh, and if you're going to use specific GPS tools, there the accuracy is near about 0.3 meters or which lies between 0.1 to 0.3 meters. So that you can just uh, uh, you will just whenever you will analyze any positioning system with the help of GPS tools, the accuracy is much more higher than your phone. But still, phone is also giving a very good user experience. But it is having one drawback also. If you're going to use this in some covered areas, suppose if you are traveling in a metro, and that metro is like if you are traveling in a Delhi metro, that metro is and in some places the metro is going through uh, uh, over the road where the sky is open, and when if that metro is going underground, the GPS will not work because it's a covered area. GPS always works in open areas. So the space segment is composed of orbiting 24 satellites, 3 pair of satellites, GPS satellites or space vehicle or GPS parlance. The orbit are arranged so that at least 4 satellite is always within the line of the sight from almost everywhere on Earth's surface at any time. Each satellite contains 3 high-precision atomic clocks and constantly transmits radio signal using its own unique identification code. GPS receivers may mainly have 2 types of frequency. First one is 1575 megahertz L1, which is used for civilians. 22 12 20 1 227.60 megahertz is used for military services or highly private services, where the accuracy is much more higher, and it will give you lots of data. So signal that can pass through clouds, glass, plastic. This signal it can't be obstructed. This is having higher frequency, and it is only used for some specific works. Plastic, but do not much solid materials like building or terrace, etc. Each signal contains 2 pseudo-random codes named as P, protected and precise, and CA, course acquisition. P is for civilians and CA is for military survey. So here you can see the control segments of GPS satellites by tracking them and providing them the correct orbit and clock information. I think you all must have seen this Mission Mangal movie. There you will find at during that launch, or they were discussing something that our boat is. They have sent some boat to monitor the satellite also. So this is how this GPS section actually works. So even here also you can see these are the master control stations: Hawaii, Colorado, Ascension, Diego Garcia, and Clarin. So these are the master control monitoring stations through which actually they are having large ground antenna stations for to get the final information coming from these stations and providing information of the GPS receivers. So there, how they will actually track down the GPS satellite. And here you can see this is the signal from one satellite. The receiver is somewhere on this sphere. Uh, Here you will see this is the receiver is somewhere in this sphere. Once you have started any GPS services, first of all, it will connect with first satellite, and this transition is very fast. It actually won't take more than 2-3 seconds. So first of all, it will connect with two satellites. One satellite, then it will again connected with the second satellite. This yellow dot is you, and now the first satellite and two satellites are giving you the information. Like first satellite is giving you latitude and second satellite is giving you longitude data. Then the third satellite usually comes, which give you the value of altitude. Suppose the MSL level also. So that's what this three satellites is working on, which always give you 2D positioning. First one is giving you latitude data, another one is giving you longitudinal data, and third one is giving you Z, which is called as altitude, X, Y, Z. So these are the three data they are started giving. And this is a three-dimensional positioning, always giving you all the details. And at the end, they will give you the fourth observation of this satellite, which will improve the accuracy of that particular location. Suppose you are standing, if you have got XYZ, but the calibration is not well, so the fourth satellite will come over there and it will give you a proper positioning system, and where the accuracy is much more higher in comparison to these three satellites. So these are the four satellite work if you'll get any GPS positioning system. So the application of GPS is in military, research and rescue, surveying, marine, aeronautical and terrestrial navigation, remote control vehicle and robot guidance, satellite positioning and tracking, shipping, geographical information system, and forestry. So these are the application of GPS. So this is one of our case where we will I have we were analyzing one area with the help of GPS. We have done it. So you can see. So this much of area we have covered by taking GPS system. So making a polygon of that particular area, and even here you can see the hydrogeological features of river. These are the lines, and a polygon is made on this area where we have taken GPS system, and the area is total 50 hectares of data, 50 hectares, and taking all this, moving from one place to another place and taking all the GPS position system through which we have made one polygon. So next is what is survey. So for mining for mining related activities, we always do survey. In earlier days, survey was done on the basis of like collecting all the ground truth data. But later on, it started with the help of like if you want to analyze the larger area, then it started with the plane, like taking photographs, aerial photographs with the help of aeroplanes. And later on, this GIS functions came on, and they have given a edge on this. Uh, this plane photography, airplane photography was, aerial photography was quite high, like expensive. But in today's world, as per the rule of MRDCA, with the rule of 2017, it is necessary to get the mining survey with the help of drone. It is also one of the essential features through which you can the survey is done. So first of all, uh, in the surveying things, you have to analyze what kind of survey you want to do, and you have to identify the area also, and you have to put questions which are necessary. Then keep it short and simple. Ask one question at one time. Avoid using jargons. So this is the all like survey features we actually perform in this steps of doing a good survey. And this, what is GIS survey? So first of all, identify the location, then uh, taking all the data from the different sources, and then we will do the modeling, mapping, and with the help of software, running algorithms and processing the data, and then you will see the some final images in the section. So this is how the GIS model works on. So these are the data slides, or we called as layers in the world of GIS. First of all, at the bottom, you can see this is your data, which we have which usually taken in points, and then the survey control areas, which is represented in triangles. Then the hydrogeological features, which is also called as water features. Then assigning the boundaries, then addresses, transportation system, all the road networks and all. Then the DEM elevation system. Then at last, after combining all those things, we can see a final image. So that is how this GIS model works on different layers. So if someone is only interested in the boundaries, so that also can be done. If someone is only interested in the hydrological features, surface hydrology, river, streams, stream orders, even all the channels. So this is one of the most important features in the mining, where actually mining people have to examine whether they are disturbing any hydrological features or not. So this is what where GIS can always contribute, uh, making all the maps to just minimize the effect. Then the transportation also, how you can transport your mineral from one place to another place, the elevation of the place by making contours. We can also make contours. I'll show you some projects images also, which I have taken, which we have processed for some mining area, um, and that I'll show you the later. So what are the importance of GIS survey? GIS is a short for Geographical Information System. It is a collective computer software and information which is used for viewing, analyzing, managing, and displaying geographical data. Geographical Information System survey create a central location to collect data analysis, which is critical for modern planning, surveying, and construction services. With GIS, professional land surveyors can increase survey accuracy while reducing cost. When you choose or select rows for your GIS survey services, you can trust your team to obtain accurate data and ensure the success of your project. So this, I have already shown it to you, real world GIS layers, and how this thing actually works on. So how this GIS is used, it actually allows people to see the world in different way by mapping the position and quantity of things, mapping the density of the people, and object mapping any changes that occur. Environmental geography is one of the most important features to analyze the impact people have on the environment. Physical geography to study the elements of atmosphere, biosphere, and geosphere. Emergency management information system to give real-time data to emergency respondent about the geographical layout. Health geography is one of the most emerging feature right now, where actually monitoring the health kind of thing. Recently, we have done one project with the health geography to analyze the malaria count or the dengue patient count last year. we just have to focus on the zones where actually the case is very high. So accordingly, the government will take the measures to control those diseases. So this is one of the most emerging features right now. Economic geography is also there to study the economic activities across the earth. Then the transportation geography to investigate the spatial interaction of the people or thing. So this is what things it's using. And now I'm just going to emphasize most in the mining. This was all common things where the GIS is used. Now I'm just moving towards application of GIS in mining. So mining industries utilize GIS in wide range of application. Uh, Currently, we are using it to make the DEMs, contour files, even hydrogeological maps, geological maps, even for mining sectors, if you want to see the water table maps, like pre-monsoon, post-monsoon kind of water maps, we are doing it. And even through mining, most of uh, ground subsurface water is getting affected, and the quality also can be measured, and how this mining activities actually impacting the quality of the water, like what should be the specific places or the safest places where the impact will be lower in terms of tailing mines where the tailing is usually taking place, and even controlling AMD, acid mining drainage. We actually we can design such kind of things where we can actually design those. We can actually identify where it can be stored so that it can flow through any flowing stream which can actually degrade the quality of the water. So GIS in mining has resulted in effective and optimal design of the mine development process. GIS has helped the mining industries to understand pattern relationship within complex data set in the geographical context. This has facilitated better decision making within the sector. Uses of GIS in various applications of mining, mineral exploration, geochemical and hydrology data, report generation, facilities, and tailing management and sustainability and regulatory compliances. So these are the all GIS features in various applications of mineral exploration, geochemicals and hydrology data, report generation, facility and tailing management, and sustainability and regulatory compliance are the main features we're using. So in mining process, quantification of stocks, material flow analysis, material stock analysis, material accounting. GIS application can be used. Localization of the stocks. So these are the features: collection, separation, sorting process. So these are the infrastructure assessment planning, site selection, environmental impact assessment, social impact assessment. This can all things can be done through one software which is called as GIS. So GIS gives mining companies the tools they need to operate mines responsibly and at optimum efficiency. GIS can be used by mining companies to target mineral exploration, evaluate mining conditions, model mine constructions, and display data such as geochemical and hydrogeological. GIS can also be employed in applying for mining permits, assessing environmental impact, and designing closures and reclamation plan. So this is one of the most important features through which these are the few most important features which we have mentioned. I have mentioned over here uh, to what are the extent of GIS where we can actually use this software, and how we can make your work very easy with doing such kind of works on mineral exploration also, even on evaluating mining conditions, model mine construction, and geochemical and hydrogeological data. It is always helpful for applying for mining permit, accessing environmental impacts also in time to time if you want to check it out, and designing closures and reclamation plans. So as per the new rules, if there is like I was going through this DMRC rules, with in which they have specified for drone uses also and GIS uses also, where every mining industry is supposed to submit the report in the month of April, I think, April to June, right? So for this kind of purpose, importance of GIS in mining industry is very important. So here you can see this is one of the images that is not done by us. I have taken it from ISI. And here you can see there are the trucks which is marked by green color and blue colors, where actually the excavation or the excavation what the uh, uh, quarrying of stones are actually taking place. And the red marks are those places where actually the quarrying is completed, and right now it's a vacant place. So this is what one mining industries through which we can actually examine the GIS kind of things. So specific use of GIS in mining, GIS in exploration. GIS is ideal for integrating various exploration data sets such as geophysical images, geochemistry, geological map, radiometric surveys, boreholes, and mineral deposits. So it is very good for using all those things. GIS gives explorationists tools to manage, display, and analyze data, resulting in successful, cost-effective discovery of new mineral deposit also. That's all things we are doing right now. And actually, we are also giving too much like in this such kind of works. I'll show you our presentation like later on. I'll show you some images which we have developed for some mining industries, and there we have explored the minerals deposits also. So that I'm going to show it to you later. So in mineral exploration, uh, actually this kind of exploration exactly uh, relying on spatial data. Most of the mine covers vast expanses of lands, requires access to location-based data to inform their mineral exploration missions. GIS technology facilities mineral explorations via gathering, storing, and providing access to large spatial data sets. GIS collects information on the spatial location of various minerals and uses it to guide mineral experts on where the best to focus their efforts. As a result, GIS can reduce cost and increase the efficiency of the mining operations. One of the most important features everyone has more like after in saving the operational cost also. So GIS will help you always in reducing the cost and increase the efficacy of mining operations. So here, how to use GIS in development and productions. GIS can be used extensively during the development and production phases of mining operation. Reserves estimates, annual plant production. So we can help you in determining the reserve of any mineral where for whatever mineral the mining is taking place. So estimation of that and annual plan production also, that you are supposed to submit 5 year of plans to get the EIA approval. So that also can be done with the help of GIS. So GIS is used by mine planners to establish the optimal location for exploration drifts, crosscuts, sublevels, manways, and ventilation shaft. So that also can be done with the help of GIS. Like you can plan it, and you can actually point out the optimal location for the exploration drifts, crosscuts, sublevels, manways, and ventilation shaft also. GIS is used to find the lowest cost path to route delivery of the supplies of working areas, find the closest facilities, establish which area are within service range, assign, assign proximity, model inaccessible areas, and model mine ventilation networks. So this all can be done with the help of GIS. We can actually, through the aerial images or through the satellite images, we can actually find out which should be the working areas, and how to find the closest facility. So which area is suitable to just to like set up a service range, and proximity model inaccessible areas, which areas would be inaccessible and where the difficulty will be higher. So all these things can be developed with the help of GIS softwares. So next is how to analyze geochemical and hydrogeology data, one of the most important feature. So see, I'm hailing from one of the mining area where coal production usually take place. I've seen from my childhood days. My father was working with Coal India, and I have seen from my childhood this is how this all mining process actually works in, and how much organized or unorganized this sector is. I think you all must have seen this kind of things, and with the help of this software, actually you can uh, see or organize your sectors, and there are multiple cases as recorded because of disasters, hydrological disaster, because of suppose uh, uh, the river water is entering into the mine pit and disaster is taking place. So these kind of things actually takes place in the mining conditions. Even the challenges which we are going to face in next 2 decades or 3 decades because of climatic changes, and the heavy pouring which actually occurring in very that heavy pouring in short duration of time, which actually stops the work of mining activities. So this also can be avoided with the help of GIS softwares. So these are the significant how this geochemical and hydrogeological examination usually taking place with the help of GIS. So minings are the significant source of pollutions to the local environment. I think you all must be agreed, whether it's air pollution, whether it's water pollution, soil pollution, even on vegetations also. So at a very higher extent, it affects because the deposition of dust on the leaves of the plant, and it will start basically it it always retard the growth of any vegetations. So with the help, like all these things can be examined. We can, with the help of this software, we can actually examine the vegetation growth also, and the cover thickness surrounding the area of mining. Vegetation patches actually can be examined or observed. So it is the responsibility of mining companies to ensure their operation do not contaminate the local water, air, and land. Pollution transport in soil is significant problem contributing to mining pollution, and it is heavily associated with the local hydrological characteristics. So GIS always collect and analyze the data on the spatial variation of heavy metals enrichment in the local soil. This is one of the most common cases, helping mining companies to understand the extent of leaching occurring in the surrounding area. This data can help guide decision regarding the mitigation of the pollution. So these are all the plan which can be, we can help you in EMP also, environmental management plan, to analyzing all those data and what kind of measure you want to take in this to contaminate less the local water, air, and land. So that's how the GIS software can help you out. It also gives you to bring use to generate geochemical data sets by quantifying changes in the environment traces metals. This information further assists mining companies to understanding the extent of environmental pollution, prioritizing AMD, mine drainage. Sorry, the spelling is wrong over there, and stream remediation. Conceptual regarding using three-dimensional GIS to evaluate mine reclamation. Then the last point of your mining is mine closure and reclamation. So GIS mapping allows you rapid sizing, plotting of the mine openings. So with the help of GIS, we can actually examine what is the size uh, or the plotting of the mine and what is the opening of the mines, waste piles, then cultural features like for accurate drawing and quantity computational during office design of the closure. And the GIS database provides streamlined storage for all pertinent information. Like I have already shown you one polygon we have made with the help of GIS, GPS, and even with the help of GIS also we can make such kind of things that I'll show you, and that will help you how to take actions on what is the size of opening and what kind of measures you have to take to uh, actually. So these are the all. 1 minute, please. So these are the all GIS database provides streamlined storage for all pertinent information regarding the mine features, including locations, access routes, photographs, tabular summaries, and dimension that lands, ownership, and notes regarding each location. Three-dimensional views generated by GIS system can be used to illustrate the pre and post recognition design features. So these are the things can be done with the help of GIS. Then at last, the report generation. The GIS gives mining expert access to wealth of data. It offers the opportunity to generate rich reports on mining practice. This data can help mining companies understand different areas of their operation, helping to streamline their process and reduce the environmental impact. So facilities and tailing management. In the US alone, the mining industries generate 1.8 billion of tons mineral processing waste each year. So this is the report I have taken from American Mining Association. And if I'm going to talk about India, where I have taken this data from Indian Bureau of Mines, where 170 million tons of solid waste related to mining are generated in India every year. So this is the estimate which is taken by Indian Bureau of Mines. And worldwide, thousands of mine tailings dams exist holding massive volumes of toxic mining waste. Mining companies face increased pressure to improve their waste management process, are often thought as being just as much waste management companies as they are mining companies. So these are the issues which right now every mining sector is facing to actually like how to actually sort out the waste issues. Because of this, there are numerous environmental impacts also they are facing, and pressure from the governing bodies to control it. That is one of the major objective now it has been become, because the moment the people will start raising voices or start observing the things, it will create issues with the mining companies. But still, it is one of the most important sector of any nation. According to Indian Bureau of Mines or GIZ report, in 2010, mining was contributing near about 2.7 uh, percent of GDP India, 2.7 thing, 2.7 or 4.7. I can't recall the data, but it was something 2.7 or is 4.7 in GDP contribution. Even it is giving more employments to the people, but still there are plus points, but positive points also with the mining sector, and there are some negative points also. In both the sections, GIS can help you out to increase your efficacy in the mining sectors. So this is one of the features I have taken from one of the research paper. And this is the area which is located in Brazil, somewhere in Amazon. As you can see, this is one like aerial photograph which is taken from uh, drone services. Here they have, here you can see this is the mining areas, and they have marked the lower impact areas also. So if someone is going to store something, or they are going to pile up the mining waste also in these low impact areas, the impact on environment will be very lesser uh, in comparison to anything. Even you can see there is a green vegetation patches over here in the northern side of this image. This is the all sectors. So let's see, just with this, I'm just going to discuss one small case studies related to Brazil only. Uh, with a for the tailing dams. Uh, so holding all the waste current in the tailing dams was insufficient in this uh, Brazilian area, but it was risky. Uh, as you must have seen the features like that dam failed in uh, Brumadinho, Colorado de Fijão iron ore mine in the Brazil. In 2019, Brazil suffered its worst ever industrial accident. It sent millions of tons of toxic waste flowing through into the surrounding rural area, destroying the village of Feijão and killing 270 people. So this was the one of the most environmental impact. And with the help of GIS, we can actually identify which area will be the better, and which can actually hold the tailing, and it won't affect. We will try to select those kind of area which will be far from the settlement area, and through which it can be the in such kind of cases the impact can be minimized. The help of GIS in disaster. GIS-based tailing spill path model was developed to help mining companies map out the quantity, and potential danger their tailing dam poses. These numerical models successfully carry out risk assessment of the tailing dams, and it will likely be implanted more widely across the industries to increase the safety. Mining operations are intervened with various social, economic, and environmental aspects of the area that they occupy, and with the help of GIS, it can be observed and marked also. So here we are going, I'm just going to show you our work, like how we are going to do, what we actually do, and what are the features actually what kind of work we actually perform. So these all our works is done by TGIS. As you can see, the first image is town planning land use mapping. This is done in mining sectors also, just to analyze how the mining things is getting increased, and what is the land use. So land use can be done in decades or in the intervals of 5 years or 2 years of time. So that we can actually see what are the changes are occurring within the with the time in that certain area. So this is the town planning of land use. You must this blue color represent, sorry, this blue color represents the area uh, which are settlement, and this green colors represents all those area which is with the patches, and the lines, as you this blue color, the dark blue color is the river. This is the town planning for Surat city, I think. Yes, this is Surat city, and here you can see infrastructural land use, where the infrastructure can be used. This is the red colors actually depicts the higher vegetation, like patches of vegetation with higher like density is higher, and the higher resolution land cover is also you can see over here. Here you can see the pink patches even on this, even this green color patches, as you can see, this is all the forest area, and this is where the settlement is actually taking place, this pink patches, and one is road one. And we are also doing mangrove classification also in for coastal areas. Suppose some kind of mining activities are taking place at coastal regions, and for such kind of activities, we also do all these activities. And this is agricultural land use, identifying all the agricultural area in this section. So this is one of the most important features. Then green belt mapping also we do. Tree species cover maps. As you can see, this is the first maps. And in this map, we have examined all the tree covers, and this is a type of canopy according to the color range. So if you'll zoom it out, you will you will see this is the where what kind of trees plantation is usually taking place. In such kind of things, uh, uh, always in mining sectors, my suggestion is, as per my knowledge or as per my research work, I have always suggested go for local resilient plants, which actually can withstand with the mining pollution or particulate matter deposition on the leaves, where actually they can survive. So that can be done with different kind of studies, examining the local resilient plant, which can be helpful for making green belt in certain locations. Then enhanced vegetation map you can see over here. Uh, then the green belt map again, the high resolution industrial belt, as you can see over here. All these maps with all red colors is is with the green belt mapping, and land industrial land cover maps also, where industry is usually taking place. This blue color represents the industries, and these all are the basically all areas where actually this vegetation covers is getting you can see over here. Then these are the some works which is related to environmental impact assessment. This is one of the land use mapping of Chembur. I think this is a project of Mumbai, and this is one topo sheets. Geological maps we also do. False color composite maps. Also, we actually make elevation mapping, hydromorphology, slope mapping, soil mapping also, different kind of soil in 2 kilometer buffer, in 5 kilometer buffer. Then locality mapping also. Then another project of hydrology water resources. So here you can see the catchment area, watershed mapping, and these are all system canals, or you may say channels through which water is flowing from one local sources, from one order to another order. So here you can see the order is also mentioned 1, 2, 3, 4, 5. 5 is the mainstream and how they are contributing. This first order, second order, third order, and fourth order, how they are contributing to the mainstream over here. So that can also be examined with the help of a watershed mapping. Then this is one drainage density of Sabarmati Basin. As you can see, morphometrical analysis. Then we do flood modeling also. One of the most important feature of where actually if some mining activity is taking place near some river, so always there is a threat of flood, or suppose like all I have already discussed, if in this changing climate season where we are seeing higher intensity of rain for shorter duration of time, which actually create urban flood. So for to avoid such kind of conditions, we actually make flood modeling, then water resources modeling, climatological modeling. Now, this is the industrial surface hydrological temporal water table type. So this is what we can examine, which is the lower area and which is the higher area. So lower areas are always prone to water logging, and which will stop the miners' work, or so that can be examined with the help of GIS. Then again, this is the one of the most important features which can be used in mining, water vapor maps, that is done with the soil. Uh, to examine which areas higher always having higher vapor content. Then digital terrain modeling, surface water cartography also. that can be done. And again, this is what somewhat groundwater modeling we actually do. Contamination transport modeling for examining how the contamination is transporting from one place to another place, how much time it will take. It actually works on groundwater modeling. That is my specialization area of mod flow. Well extraction mapping, then seawater intrusion, then aquifer modeling also, as you can see, groundwater contours, that also can be done. And here in mineral exploration, as you can see, this is one of the most important feature which we have done in Western Ghat area or maybe in Odisha. So this pink color denotes those area which is higher in uh, ferrous iron content, and blue color represents those area where the content of ferrous iron is very less. Then this is higher resolution mining map, as you can see. Another one is mining lease planning, the third one. And here you can see I have already mining lease plan, I have zoomed it out. So this is what for first year, only for a year we have made this one. And if the client requires for 5 years, 6 years, that we can also do. That is what that all the details we have received. So that's how we actually examine the things in the mining region, also mining lease planning. So at the what how to become a GIS expert? Now you must have having some question. For achieving a career as a GIS analyst, few things are very important to make clear-cut decision about your career. There are some steps which I'm going to discuss. First of all, you must have some academic degree in geography. If you are having geography, it will be preferable. Environmental engineering, computer science, surveying engineering, forestry, earth science usually are the minimum education needed for to become an GIS expert. But still, if you want to learn it, you can learn it with different college, university coursework, and the training labs like TGS. We provide also trainings to if you want to learn the software and real world experience, which are essential in helping GIS analysts to reach their career goals. And GIS expert salaries, scope, and nature of the work. So industries are mining, supply chain management, insurance, forestry, timber, urban planning, banking, health, and human sciences. Eligibility I have already mentioned. Though, so the average starting salary, those who are freshers, they will get near about from 3 lakhs to 12 lakh 80,000 rupees, depending upon the type of the organization. And the job options are GIS technician, GIS specialist, GIS developer, engineer, and programmer. So types of the GIS analyst are there are one of the most coveted jobs role in India. Aspirants who want to willing and make career in GIS analyst can have look at list below a list below. So environmental specialist, geographer, data analyst, and data scientist. So environmental specialists work on different kind of conditions like environmental impact, making all the things. Geographer works with different organization like with um, home ministry also, with spying police agencies and all everything, even on forestry. There are different sections actually which where GIS analyst is working currently. So there are many fields in which actually a GIS candidate can explore his or her career: climate scientist, conservationist, forester, GIS manager, health geographer, firefighter, remote sensing career. So this is what GIS mapping services we actually provide: geospatial solution, consultancy projects, research analysis, webinar, workshop, and GIS trainings. And this is our services in which we are currently dealing with: land use mapping, forestry, green belt development, green belt mapping, ecology and wildlife conservation, agriculture, EIA, carbon credits, hydrology, water resources, groundwater modeling, geology, urban planning, climatology, and meteorology. So these are our prestigious client: Reliance Industry, GMDC, ONGC, Good Carbon, Nature Conservancy, even Forest Department of Gujarat, IIFM, BNHS, NABARD, NI, MET, and CPT University. So these are the few agents, like agencies, which we are working with. And this is the 2 days international webinar training which we are going to perform, which we are going to give on 24th and 25th of February. If somebody is interested, you can just come over and you will see what we are teaching over there. And this was all about our presentation, but I'll show you few EIA impact maps also that we are doing. Just wait for a second. I hope it is visible to everyone.
Yes, yes, Saroji.
This image is visible to everyone.
No, no, not the image. We could see only the PPT.
Okay,
Just
just
stop
wait a minute.
sharing and reshare the screen
Ah.
again. Yeah.
So is that image is visible to everyone?
Contour map of the study area.
Yeah.
Yes, we could see
So
that.
this is one of the mining area which is located in Bhiwani. So I can't disclose the details of the client, but I can show you the images where it is. So this is electrical conductivity map. This is all about. This is the geological map and geomorphological map of the study area, where you can see the geomorphological layer of that certain area. With the help of GIS, we have developed this, and hydrogeological maps. Also, this kind of work we also do. The land use, then depth to the water level, pre-monsoon, post-monsoon, the contour plan of the project site. This is the 5-meter buffer of the map of the study area, as you can see. This is stone quarrying activity is about to take place. And this is a project site location, topographical map of the study area within the 10 kilometers, water level fluctuation pre and post, water quality, fluoride, chloride, nitrate, all those things. And this is the control map once again. So this is what we actually do. So if you have any questions related to this, you can just ask me up.
Yeah. So if someone has question, please raise your hand. I'll just give the mic permission so that you can put it across your questions, please. You can stop sharing the screen, Saroji.
Yeah, thank you.
So meanwhile, I'll read it out few questions which you have already listed in the Excel sheet. I mean the chat box. Uh,
Yeah, let me read, sir.
yes, yes, please. So one question is from I think Nirmal Kumar Munda. He is asking that how remote sensing is utilized for risk management.
GIS can be used in risk management because GIS is more advanced software, and through which actually we can actually examine the risk related areas with the help of DEM, digital elevation module. Uh, and we can actually examine which are the higher risk related areas. Suppose recently we have done one project in Himalayan region, which areas are more prone to landsliding. That kind of studies can be done with the help of GIS. So it can be done in mining industries also. It is somewhere the excavation and the geological features are taking over there. So depending upon the slope of the mining area and contours we can design, and we can actually probably find out the specific area where actually which is related more towards any kind of disaster. So that can be done with the help of the software.
Perfect, perfect. And Hemant Jadhav was asking a question that, sir, can you please show some pictures of sensors? What kind of a sensors? I think the question is not that clear. Uh,
Sensors, sensors is like it's very difficult to show, because sensors are placed in uh, like, suppose you are using a camera, that is also a sensor. You're using a phone cameras,
right.
that can also
So
be.
means Hemant Jadhav, if you could able to tell me the precise context of what sensor you're talking about, or which sensor. Thank you. And Nirmal Kumar Munda waiting. Sorry, weighing. We can do risk management of land susceptibility, flood risk, and forest fire. Right. Whether he's stating this or asking a question, I don't know. Well, fine. Which type of softwares are used in the mining sector for using GIS?
ArcGIS and
The question from
QGIS we
Sayan.
used. ArcGIS is one of the software which you have to purchase. QGIS is open domain software, where you can actually use this kind of software. But making good models or making mining related things, you need some specific trainings actually. And that's what FIMI and TGS has collaborated, and to give such kind of platform to you people to actually explore the software of GIS in mining sector, how to use it, and how to analyze the mining sector with the help of GIS software. So that is why we are here.
Exactly.
Uh,
Correct. And just adding to your point that, RGS is more of a, user friendly, and by looking at the YouTube tutorials or self-running tutorials, okay, the basic idea of this particular mapping and these things will, we will come to know, and, we can get the knowledge out of it. Yeah,
mhm.
right. And the question is from, I think, a point from Abdullah. It says that we can use QGIS software for the
Uh,
overall survey boundary operations. That's right. So he has shared the web link for
mhm.
of ISRO, where you can get the basic information about geodata.
Yeah.
Thank you, Abdul. Yeah, and Mr. Rajesh says that waste management is a very complicated process for every mining expert, but only a geological expert is planned systematic scientific planning for waste management and minimize the impact of mining.
It's a statement, sir.
Yes, Rajesh.
I
Yes,
agreed with it.
Rajesh,
Yeah.
very true, very true. Yes, we acknowledge your statement. Um, yes, we need a detailed workshop on waste management because it's gonna play a huge impact on this minefield nor other fields too. Well,
Mm.
sir, what are the necessary GIS courses from Frasan?
First of all, you have to know the basic from where you have to get the data. That is the most important thing. Suppose what kind of if you want to do some kind of decadal work, what kind of data you're going to get. And suppose you are going, if you want to work something precise on very detailed kind of modeling, that from which satellite you have to take the data. That are the basic things. First of all, you have to know, and then only you can proceed. It is just only the basics things you have to learn first, and then the advanced versions. Then only you will find out how this software is working and how this process is actually taking place. Because whatever images I have shown it to you, that required lots of algorithm and calculation, and then only it will process. I've shown you one image of mining, uh, that iron ore mining one. So for creating such kind of images, it took near about 3 to 4 hours for us. because it algorithm was running in the background, and it was taking quite high time, because taking all the ground truth data and analyzing it will always take time. So there is no such kind of courses is designed, but we are designing with the help of FIMI, and we are going to introduce it to you very soon. I think Sudarshan sir will be handling all those things, so he will already, you will get to know about this. We're planning for it.
Yes, yes, very right, Saroji. I think I hope Abhishek ji got the Prasanna got the answer. And there is a question, I mean, a request from Abhishek Krishnan sir. Can you please share the workshop registration link? Yes, of course, we will be sharing the registration link. So I'll be sharing the participant details with you, Sauravji. And those who are interested, you can please send them the registration link for the
Sure, sure, sir.
workshop which are planning on
Sure, sir.
24th and 25th of this month. Yeah.
Yeah.
And this question is from Anthony Alosanai. So he is asking that for doing groundwater potential zone mapping or vulnerability zone identification, validation part is highly required or not? Will you recommend it or not?
Mr. Anthony, I have one question. What kind of validation part you're asking? Because there are too many things in the groundwater hydrogeological features. Basically in subsurface modeling, where we actually take too many considerations, because things are not visible very clearly. Uh, it always changes from one aquifer to another aquifer. Somewhere you will find out some zones where the water is available, and some zones with a mixture of some kind of geological features where water presence is very less. So I'm just little confused about your validation points. If you make it clear, I'll be happy to answer you.
Yeah, yeah. So please, you can you can send those questions to us, Antony ji. Next question is from Chitrala Venkateshwarulu. Sir, can you share the PPT presentation? Yes, yes, Venkateshwarulu garu. Definitely, we'll share the PPT as well as the recordings. Uh, Again, question from Nirmal. Any case study where GIS is used to optimize the routing and queuing of haul trucks in mining? What is the cost saving and efficiency? How will it be differentiated from fleet management system? Over to you, this question.
So So even I have to find out this kind of study, but yes, that can be done with the help of GIS, optimize the routing, and queuing of haul trucks is a different thing, because it always depending upon the availability of the space or something. So that also can be done with the help of GIS. Yes, with the help of software, we can analyze the cost and saving and efficiency by routing taking the shortest route, where the organization can save money, or by saving fuel also. So that is what we can do. And so fleet management different system is a different thing actually, that can be managed on ground. Uh, because yes, we can give you we can locate a proper space where you can park those vehicles with the help of the software, but the management kind of things, that is something which you have to perform on the ground also.
Yeah, exactly. I just want to add a point over here. See, a fleet management system is an application or a program or a software, whatever you want to call it. It is a dedicated one. So it takes care of each and every aspects of a fleet. Maybe the queuing or a halting, or maybe the real-time monitoring, or you can say the fuel efficiency, the per kilometer consumption, the mileage, everything. So that will be embedded inside the coding or programming. But as far as GIS, yes, you can do the queuing of the aspect, but the thing is the application as fleet manager. So if you compare on the both hand, you cannot compare apples and oranges together, man. So it's like that. Yeah, perfect. Right. So the next question is from Samula Shivkrishna Reddy Garu, that how far is remote sensing useful in open cast mining? or production mines, where we can get the satellite images and what are price ranges for one image. Okay,
Okay.
now you have to, yeah.
See, there are few satellites which is giving you images free of cost. Like from Bhuvan also you can download it, Indian satellite. But if you are looking for latest datas, or suppose if you want to see some data which is only a week old or 2 weeks old, for that you have to pay the prices, or for that you have to contact to the agencies. Right now, even I will tell you some random amount that will, I think it will not justify the thing. So my suggestion is you can contact to the different agencies which is working in this remote sensing sector. Even on ISRO, you can contact, you can get the price range from there. But yes, kind of satellite, what kind of image and what kind of accuracy you are needing, that exactly is somewhat which is related to, like NASA always give you 30 by 30 centimeter of like details, and there are some Japanese satellites which will give you 10 by 10 meters of details. So these are all things which is available in the market, but you have to, according your, if your work according to your work, you have to decide what kind of like projection or details you need, or what kind of imageries or zooming quality you want. Based on that, you have to purchase your images, and that
Perfect.
will always give a different section of price range according
Right.
to your images or
Right.
requirement.
So Saroji, I mean,
Yeah.
it's a fantastic question by Reddy Garu, and I think even for more details, he can contact that GSI website. I also know. So they started a. I'm not sure exactly what it is, but for providing this particular remote sensing data, they have a separate portal. So
Yes.
just a couple of weeks, they have launched a separate feature. So Rediger, once you can just go through that particular GSI website and you can get more details. Yeah. The
So what
question
is
is from Sumi. What is
Sumin Gorai?
electrical conductivity map? Yeah.
Okay, it's a water quality, physical quality of water. Actually, it depends upon what is the solutes present in the water. According to that, every what electrons or proton presents in the water actually pass some kind of electric current between them. So it exactly show you what is the electrical conductivity. It is always measured in microsiemens per centimeter. So suppose you are taking some water, like 1 liter of water from the groundwater, exactly, and it will show you what is the if the number is very high, uh, that means dissolved solutes in that particular water is very high. Suppose you are getting the like number of 700 mu centimeter microsiemens per centimeter, and that actually indicates the solute present in the water, total dissolved solute present in the water is very high. So that is
So,
what electric conductivity map is.
right. So I think a lot of chemistry will come into picture. Alkalines, colloids and all,
Yeah,
especially the
yeah.
electrical conductivity. Right. Perfect. Perfect. And the question is from Nirmal Kumar Munda again, that what are the counts of a ground reference points to be set at mines, minimum and maximum for GIS studies of a mine?
Sir, it always depends upon what kind of work we are doing. Suppose if you want to take some kind of point features, that will be only limited to that certain places. But if you want to make a polygon, then we have to take multiple points. That is not actually it always it is always dependent on the work, what kind of work we are going to do. So the taking counts on the reference point is always dependent on the points which we are, what kind of work we are doing.
Perfect. So I think Mr. Abdullah has raised his hand. So Abdullah, you can ask your questions directly to Dr. Saurabh, please. I
Good
have
evening,
enabled
sir.
your mic. Yeah.
Good evening, sir. Actually,
Good
my
evening.
question is about that mine automation is coming to role now, sir. Now, in upcoming futures, they are using some mine automation using artificial intelligence. Thus, this also has some any automations in the GIS. I'm asking like that. Does it play
Uh,
any role in our future?
Right now, there is no such kind of automation thing because, but yes, developers are working on it, and hopefully in near future we'll see something new in this.
Okay. Okay, sir.
Yep.
Because we can also integrate this with GIS, no, sir. Artificial intelligence, it can and save us a lot of time of us in
Yeah,
spatial data
yeah,
impacts.
agreed with you. But it is
Yeah.
always, but it is going to hamper the GIS expert job also if everything is related to AI, because we are discussing also future of GIS, even the like how you can become a GIS expert. If everything is incorporated with AI, I think that human touch will be missing over there.
Okay. Okay. Thank you, sir. Thank
Yeah.
you, sir.
So, good question, Abdullah. So, where are you from, and can you give me your introduction, please?
Actually, I'm a student from mining engineering from Karnataka, sir. Currently, I'm doing my third year of mining in Dr. Tinmay Institute of Technology.
Oh,
This,
so okay. So I'm the alumni of the same college.
yeah, thank you, sir. Thank you, sir.
Good, good, good. All right. There is a question from Chavan Kaveri Gopa. Sir, how the
Uh,
GS expert has a scope as a firefighter?
Sir, firefighting, like, I think how much I can assume in this section, because with the help of GIS, you can always draw some shortest route to reach some location where actually fire incident takes place. Uh, but what are the disaster prone areas related to fire where actually the firefighters requires that exactly we can examine through the GIS software. Like suppose the incident of fire that is happening at some places very high. Recently, I think 2 years back, we were working on some ecological projects related to forest fire. So in such kind of cases, we can actually take help of firefighters also to save our like jungles or forest to from the forest fire. That where actually GIS expert can help you out.
Perfect, perfect. And anyone who would like to ask a question directly to Saurabhji can just raise your hand, please. So meanwhile, I have a personal question from my end. Okay.
Sir, sure, sir.
So, so the thing is that the guy, I mean, because this particular webinars are, it covers the students also, the industry experts also, everyone. For a guy who is very new to this particular technology, or for the first time, maybe he might be hearing the words of push broom, whisk broom, and all. Okay, so if you want to, if you want to see his career, or if you want to kickstart his career in this particular GIS field, like what is the foremost thing he needs to do, Sauroji?
See, sir, first of all, like I have already given, we usually give some FCC images, first of all, RGB or kind of things where actually the color compositions, we actually do the work of any processing of the image, first of all. So when I was a student, first of all, I got my first image as a black and white image, like DEM image I have received, and my teacher asked me to analyze it in RGB and
Hmm.
just put it in the software and put it in RGB mode and try to find out what according to the reflections. So I was unable to do that because I was so first of all, the first interaction should be like that, where actually you will amazed how the things are appearing in false color composite, because everything you are seeing in real world is a in different color, and in GIS processing images you will find out some things which is related to FCC, where you will find vegetation in red color. The thicker vegetation, it will appear more in maroonish or reddish kind of thing. The agricultural field will appear light reddish or pink color. The reflection of water bodies, it will appear blue black in color or greenish black in color. The settlement area will appear in gray color. the mining area will appear in different color. So that was my first interaction. And later on, I have started with vector kind of files where I have to put the points, then I have to make the lines, I have to cut out the area, make the polygons. So that is the basic interaction through which actually uh, even now I try to make the student very comfortable if they want to learn it. So starting from very slowly and basic things, and later on introducing all the advanced features of the software. So that first of all, he will learn what are the things, what are the basics, why we are calling such kind of things, what are the pixel values, 0, 1, how the things are actually working on over there, how the things will appear if we will see from like one location to another, like from one height to another height, like what will the picture of geostationary satellite, what will be the pictures of orbiting satellites. So that's all are the different things that actually we introduce the things very slowly, so that even the student can enjoy the things and even he can analyze how the things are going on.
All right, perfect, perfect. So we have Amini. Sorry, Amini ji, you can ask your question, please.
My just I am telling that you are asking that GSI portal, that is a NGDR portal. We can download all the images, sir.
Yes, yes. Thanks a lot, ma'am. Thank you very much.
Recently GSI has launched that websites and portal. So this is NGDR portal.
NGDR. Thank you. Thanks a lot. Thanks a lot, Amini ji. Yeah. So I think Sayan Mandal, you had a question. So all right. I think no more questions. So
Yes.
so first of all, the thing is that it like always this kind of a webinar, whenever I come across this particular webinars, no, I observe it very carefully. I listen to them very carefully, because as a mining engineer, I'm a old mining engineer, passed out in the 2010 area. At that time, this particular GIS or drone aspects and all, which were very new to us, right? So, but when I heard you and when I started to gain the knowledge from you, no, so many more things came to my mind. I know many more things I learned today. Especially, first of all, I thanks a lot from bottom of my heart, and I thank the entire TJS team, which you have put a lot of effort to prepare that particular PPT, and you have given a lot of thrust, and you have given a lot of effort to make that PPT very effectively. Okay, so first of all, thanks a lot for TJS as well as to Dr. Saurav Ambastha. And if someone could, if you someone want to share their experience, how they felt, the feedback, if they want to give, so please they can give. Just raise your hand, one or two. I will take the feedback and we will conclude the session, please. So anyone? So it's an opportunity for you. Okay, so we have a nice gathering. Okay, so we have Kaveri ji. Let's listen from her. Yes, Kaveri ji, over to you.
Hello, good evening, sir.
Good evening.
Good evening.
Sir, as I am a UG student from second year doing my BSc in geology, sir, the way you explained the GIS in the mining sector was really very like appreciable. Like really, I was even it is a very deep topic. Then too, I was getting whatever you were explaining. So thank you so much, sir, for your such a wonderful session. And in future, I would like to attend such sessions. Thank you so much, sir.
Thank you, Kaveri.
Thanks a lot. Thanks a lot. Very good, Kaveri. All right, all right. Is there anyone who would like to share their feedback, please?
Hello.
Yes, madam. Yes, madam. Please.
Yes, madam.
Sir, myself is Yamini. I am working in the MSPL Mineral Sales Private Limited, and that sir is presented very well, and it is very useful to in mining sector. And so many times we are field area is very tough and we are not going, then we are tracing that mineralized body by this lineaments and everything. So it is very useful, and I highly thankful to sir. So it is very nice presentation. Thank you, sir.
Thanks a
you,
lot.
thank
Thanks a
you.
lot, Amini ma'am. So, ma'am, MSPL, you are at corporate head office at hospital.
Yeah, sir. Hospital.
Yeah. Good, ma'am.
But
Good to see.
I'm transferred in Gadak Gold Project. It's near about 90 kilometers away from near to Hubli.
The Kappat Gudda.
Yeah. Kapat Gutta
Yeah,
Reserve Forest.
yeah. Because I am from hospital, ma'am. Thanks a lot.
Okay.
Right. All right. So it was a very wonderful, nice session, Dr. Sauroji. And whenever the time permits, so definitely would like to have a session once again.
Sure, sir.
And
Sure, sir.
FIMI as well as Skill Council for Mining Sector, we are highly indebted to you. And thank you very much once again.
No, sir, we are thankful to you, sir. You have given us opportunity to present our work over here with the on the people who are present from the mining domain, and in presenting in front of them. So thank you very much to Femi and you for giving us opportunity to present our work over here. And we are looking forward to organize another program with you in future. Thank you very much.
Thank you. Thank you very much.
Thank you.
So herewith, we are concluding the session, and I thank all the participants for their patient hearing. And near future, we will be conducting a webinar every monthly once with the very need of the hour topics. Like we have so far, we have covered the topics on the drone, the topics on the new aspects, as we have discussed about the fleet management system and all those things we have we have dealt already. So we will be covering this particular need of the hour topics in mining industry. So those who are interested, they can join us. Anyhow, I have your email IDs, so I'll be sharing those email IDs, those event details with you, and those who are interested, you can always connect with us, and you can always attend this particular sessions. So once again, thank you very much, dear participants, as well as thank you very much, Dr. Saurabh ji.
Sir, thank you very much. Thank you very much.
Thank you very much, Saurabh ji.
Thank you, everyone. Those who have attended today's webinar, thank you very much to everyone.
Thank you, Saurabh ji. So herewith, we are concluding the sessions.